Hello, today we're going to look at the second half of section 10.9 about dividing radical expressions that use something called conjugates. Conjugates are two binomials that have the exact same terms but different signs. One has a plus sign and one has a minus sign. Conjugates look like this, so we're still working with radicals, but we have a binomial, two terms, and conjugates are the pair of those two items together with the exact same terms, but one plus and one minus sign. We're going to use conjugates in order to rationalize denominators that have binomials in them. So remember, we can't keep a radical in the bottom of a fraction, so we rationalize. But when there are two terms, when there's a binomial in the denominator, we're going to have to use something called the conjugate. In the first two questions, we're just practicing naming the conjugates. So if you take a look at question number 1, the expression they give you is 2 minus the square root of 3. The conjugate are the same terms, 2 and square root 3, but with the opposite side in between. So 2 minus square root 3 and 2 plus square root 3 are called conjugates. In question number 2, we still have the same two terms as conjugates, so -1 and the square root of 27, but with a different sign in between those two terms. So here the conjugate is -1 minus square root 27. In the next two questions, we're going to see what happens when we multiply conjugates together. So in questions 3 and 4, it says multiply the conjugates that you identified in the first two questions. So for number 3, we're multiplying 2 minus the square root of 3 times 2 plus the square root of 3. In order to multiply binomials, remember that we have to use FOIL. When we multiply the first two terms together, 2 times 2 is 4. For the outer terms, 2 times the square root of 3 is 2 root 3. For the inner terms, negative square root 3 times 2 makes negative 2 root 3. And for the last terms, negative times positive makes negative. Square root 3 times square root 3, as we learned in the last lesson, is just a plain old 3. Just like when we FOIL before, the middle terms often combine. Here we have positive 2 root 3 minus 2 root 3. So our middle terms are going to cancel out. We're just left with 4 minus 3, which is 1. In question number 4, when we multiply the conjugates, we have -1 plus the square root of 27, and then -1 minus the square root of 27. Again, we're going to FOIL because we're multiplying two binomials. For the first two terms, -1 times -1 is +1. For the outer terms, -1 times negative square root 27 is positive square root 27. For the inner terms, square root 27 times -1 is negative square root 27. And for our last terms, positive times negative makes negative. Square root 27 times square root 27 is a plain old 27. Our middle two terms again are going to combine. Square root 27 minus square root 27 cancels out. And then 1 minus 27 is negative 26. Notice that when we FOILed each of these pairs of conjugates, the middle terms always canceled. That will happen every time you multiply conjugates. Also notice that the middle terms were the only one that had radicals, so all of our radicals disappeared. This is why we're going to use conjugates in order to get rid of radicals in the bottom of a fraction whenever we have a binomial. So let's take a look at simplifying a fraction or rationalizing where we have that binomial in the denominator. In question number 5, we have the square root of 4 over 3 minus the square root of 5. Let's reduce that square root 4 first. We all know that 4 is a perfect square number. Its square root is just 2. Now, we're not allowed to have that radical in the denominator, but we can't just multiply by square root 5. Otherwise, we would create a radical attached to the 3. So instead, when there are two terms in the denominator, we rationalize by multiplying both the top and the bottom of the fraction by the conjugate. So if the denominator is 3 minus the square root of 5, we're going to multiply by 3 plus the square root of 5. Whatever we do to the bottom, we have to do to the top. Now we can multiply, so let's work with just the top for a minute. In the numerator, when we multiply 2 times 3 plus square root 5, we have to distribute. So 2 times 3 is 6, plus 2 times the square root of 5 is 2 root 5. In the denominator, we're multiplying conjugates, so we have to FOIL. When we multiply the first two terms together, 3 times 3 is 9. For the outer terms, 3 times square root 5 is 3 root 5. The inner terms give us minus 3 root 5. And the last terms, negative square root 5 times positive square root 5 makes negative plain old 5. In the denominator, the middle terms cancel out. 3 root 5 minus 3 root 5 just makes 0. So we're left with, in the bottom, 9 minus 5, which is 4. The numerator stays the same for now. And then the only thing left is to check to see if you can reduce anything. Notice how all of the plain old numbers not in a radical are each even numbers. They're all divisible by 2. As long as every single plain old number has a common factor, can be divided by something, we have to reduce the fraction, but only if every one of the plain old numbers can be reduced by the same factor. So here, 2 goes into each of these. So 6 divided by 2 is 3. 2 divided by 2 makes just 1 root 5. And in the denominator, 4 divided by 2 is 2. This is our final answer. We've gotten rid of the radical from the bottom, and the plain old numbers do not have a common factor. In question number 6, again, we have a binomial in the denominator. So in order to get rid of the square root, we have to multiply by the conjugate. Here we're going to multiply both top and bottom of the fraction by 2 minus the square root of 3. Always multiply by the conjugate. In the numerator, we're going to distribute. So square root 8 times 2 is 2 root 8. Square root 8 times square root 3 is square root 24. I'm going to continue just with the numerator for now, so let's finish simplifying that. Square root of 8 can be broken up into square root 4 times square root 2, but the square root of 4 is 2. So this becomes 4 root 2. 24 can also be simplified. 24 breaks into 4 and 6. So I'm going to break the square root of 24 into the square root of 4 times the square root of 6. But the square root of 4 is 2. So the second term becomes minus 2 root 6. Okay, now the top is as simplified as it can get. Now I'll deal with the denominator. So multiply 2 conjugates. We always FOIL. The first terms, 2 times 2 is 4. Outer terms give us minus 2 root 3. The inner terms give us positive 2 root 3. And for the last terms, we get minus 3. As always, when we multiply conjugates, the middle terms cancel out. Negative 2 root 3 and positive 2 root 3 make 0. So in the bottom, we just have 4 minus 3, which is 1. You can leave that 1 in the bottom of your answer. You don't have to. And now for our last example. In question number 8, our denominator is a little bit more complicated. So when you take a look at question number 7, we're going to again multiply top and bottom of this fraction by our conjugate. Since the denominator is 2 root 7 plus 4 root 10, we're multiplying by 2 root 7 minus 4 root 10. Okay, in the numerator, we're going to start by distributing. Square root 8 times 2 root 7 makes 2 root 56. Square root 8 times a minus 4 root 10 is minus 4 root 80. Again, I'm going to stick with the numerator just for a minute until we simplify everything. So square root of 56 can be broken into the square root of 4 times the square root of 14, but the square root of 4 is 2. So our first term becomes 4 square root 14. In the second term, the square root of 80 can be broken down into the square root of 16 times the square root of 5. The square root of 16 is 4. So when we multiply 4 times 4, this becomes minus 16 root 5. Now for the denominator, to multiply our conjugates, we're going to FOIL. I already know that the inner terms and the outer terms, the middle two items, are going to cancel out. So this time, I'm just going to multiply the first two terms together and then multiply the last two terms, since I know the middles will cancel anyway. When I multiply the first two terms together, 2 root 7 times 2 root 7, 2 times 2 on the outside makes 4. Square root 7 times square root 7 is a plain old 7. Then for the last two terms, positive times negative makes negative. On the outside, 4 times 4 is 16. Underneath, for the radicals, square root 10 times square root 10 is a plain old 10. So now 4 times 7 is 28. 16 times 10 is 160. 28 minus 160 is negative 132. I've simplified all of the radicals. There are no other perfect squares that go into any of the radicands. However, there is a common factor for each of our plain old numbers, all of the numbers outside of a radical. Each of those can be divided by 4. So 4 divided by 4 makes just 1, square root 14. 16 divided by 4 is 4, square root 5. And in the denominator, 132 divided by 4 is 33. This is our final answer. There are no radicals in the denominator. Every radical is as simplified as it can be, and there's no common factor among the plain old numbers. Please make sure that you complete the attached homework problems. There are only 8 of them. Make sure you show your work. You will not get credit without your work.